All right, so let's take a look at the strategy design pattern. And again, as always, we take a look at a really trivial example, something that hopefully we all know, a domain that we are all familiar with, simple enough to understand, but complex enough that it makes sense to apply this particular design pattern, right? Even though it's we're going to be using this simple example, the pattern is applicable, for any particular problem where you might try to break out any particular feature in a separate class, and then say, well, how can I reuse this? And there are different ways that I can implement this that perhaps can build on each other, combine each other to create ever more increasing, more sophisticated solutions, right? We'll take a look at the tic-tac-toe game, and we'll consider, well, what would it mean to win, right? And what strategy would you follow, right? And we'll talk about all the different things that you could do in a tic-tac-toe game, and we'll see that we might have many random things that we could possibly do, but only combining them, right, and prioritizing them and building on each other, can you actually have a strategy, right? Some of the strategies might be fairly trivial, right? Like deciding to randomly choose any particular open available space, right, and put your token there. As something a little more forward thinking on perhaps trying to block someone else, right? Or the final solution of ideally of you moving finally your token into a winning spot, right? And these are all disparate strategies, right? That might not work very well all by themselves, right? But together, right, they can build on each other. That combining all of them perhaps might make a winning strategy. Make sense? Right. So here's just a few of the various things that you could do in a game, right? You could move a piece on an empty square, or perhaps in a corner, right? We might have, after playing tic-tac-toe, we might remember that perhaps starting at a corner might give us some advantage. Certainly we want to detect whether we're about to win or we're about to lose, and either promote our win or block somebody else. And individually, they might not be much, right? But if we find that putting these individual strategies in a particular order, prioritizing them, right? Definitely the object of the game is definitely to win. So definitely we want to be able to check for that, right? If ever we're near winning, certainly we want to take that before just randomly choosing any spot, right? So there is some prioritization into these strategies, right? That they should be in some order, right? They're not random order. So individually, they might not be much, right? So certainly moving into a square, a corner, block your partner, or move into a winning. But certainly, if we see that these are somewhat in reverse order of relevance, right? That we have, if we're about to win, definitely want to go there. If we see that the other partner is about to win, certainly we'll try to block them, right? And if none of these, then perhaps we just randomly choose corners or squares. So individually, they might not be much, but perhaps if we find some particular priority, we might actually come up with a winning strategy. And so, but the idea is that each one of these could be perhaps implemented separately, right? They all try to calculate the same thing. Right? They all try to calculate, well, here's where I am. Where should I put my token next? Right? They're all doing the same thing. So that's one key. That's one key feature, right? That strategies, presumably, they're all trying to compute the same thing, right? But differently. Okay, depending on the current state and depending on presumably our heuristics as human beings and trying to encapsulate or encode our knowledge, right, into a strategy. We'd like to be able to have maybe a function that perhaps say, hey, using that particular strategy, where should I put my token next? Yes? So they all have the same goal, right, of moving the next token somewhere, but implemented slightly differently. Once we've identified that these are not randomly chosen, but they actually have a particular sequence that they should be implemented in a particular order, we identify that the lowest level of the dumbest or the least thoughtful or sophisticated type of strategy would be to just randomly move in any square, right? That's the dumbest or the simplest of strategies, right? I don't know any better. I'm just going to randomly choose a next, and that would be like the lowest, right? Least the most basic or raw type of movement, raw type of strategy. Just randomly choose any place. The next higher up that might be a little bit smarter is to say, well, the next smarter thing is that having us identify, having played this and being experts at playing tic-tac-toe, we might have identified that perhaps corners are a little more smarter, right? It gives us chances to move on either direction, horizontally or vertically, and perhaps even diagonally, right? So perhaps if we could say if there is a corner, right? If there is a corner, then take it, right? Otherwise, if there's no corner, then okay, fine. Any other corner, any other spot will do. Yes. So we see that already, right? That these strategies are not typically just meant to be considered individually and isolated. They're meant to be perhaps even built on top of each other, right? Where smarter strategy might prevail if it's possible, if it's allowed, or if the opponent allows it. Certainly, I'll take that higher strategy, but I can always fall back on a less less sophisticated strategy. Yes. So yes, if available, I'll play the corner. If not available, then I'll take the less sophisticated one of just moving into the square. Yes. All right. And that's where we're always looking for these kinds of strategies. Can one strategy be rewritten in terms of another? Right, so I wouldn't want to rewrite the corner strategy, right, in terms of and having to rewrite the moving into a square. Ideally, I would be able to write the move into the corner strategy in terms of something that has already been written in terms of some less sophisticated strategy. Right, that's the key, right? That these are going to be able to build on each other. Right, that I've already implemented a less sophisticated strategy. I should be able to build and create something that is more sophisticated in terms of something that is less sophisticated. Right, and further, right? If we go a little further, something that is a little more sophisticated is identifying that perhaps my partner is about to win, right? And I want to look out for these kinds of things, right? If more edge cases, more specialized behavior. Right? If I determine that somebody's about to win, I want to block them, right? But I don't want to block them always, right? I'm more interested in winning than blocking them. I will only block them, perhaps if I detect that there's one more piece for them to win. So if that's the case, then yes, I will block them. If that's not the case, then I can fall back into a less sophisticated one of me moving into the corners, right? Or finally, if I don't have any corners, then moving into any available spot. And finally, the overall strategy, the top level strategy is I want to win, right? If given the chance of having already my two pieces all ready to go, certainly that's my first. That's my first goal. I'll move my token into that winning spot, right? But if I don't have that, then I'll just fall back into perhaps blocking my opponent, or moving into the corners, or moving into the. So we see that there's this pattern, right? That we identify all the things that we could possibly do, right? All the possibilities of moving or of different use cases in a real industrial setting, right? We would look at the analysis of what are all the different use cases, right? What are all the possible things that we could automate, right? And either calculating either taxes, something as boring as taxes, or whatever, right? And the different strategies of reducing my tax liability. There's tons of these accountants that they know all these different strategies, right? And obviously they'll try to sort them out in which strategies might be more beneficial to my particular circumstances. Yes, and depending on all these, they'll sort them out, right? And create an overall strategy. Obviously the overall strategy is to reduce my tax liability, right? But that, depending on my circumstances, will be one strategy for me and another strategy for someone else. Yes, and sort it out in that particular order that would make a strategy a winning strategy. Yes. So anyway, so let's back to something that's much more fun than taxes. So this is the winning strategy, right? If indeed the winning move is available to me, I'll definitely take it. So this seems to be like a pretty good strategy. So let's start building them. Now the interesting part will be that we can implement them individually, separately, by themselves, in such a way that perhaps we can combine them in different ways, right? And that's what's going to that's what delegation will buy us, right? That we can at runtime, based on some logic about some criteria, we could combine these strategies differently, right? And that's which we would not be able to do if we followed inheritance, right? Which would be already hard coded into our source code at compile time as opposed to runtime. All right, so let's implement the first couple of strategies.